Good morning everyone. This is the continuation of the previous lecture on precast RCC. Previously we saw the concept of precast, which is also known as prefabricated construction, that includes those buildings where the majority of structural components are standardized and produced in plant in a location which is away from the building and then transported to the site for assembly. These components are manufactured by industrial methods based on mass production in order to build a large number of buildings in short time, and that too at low cost. This type of construction requires a restructuring of entire conventional construction process to enable interaction between design phase and production planning in order to improve and speed up the construction. So in general, precast building systems are economical when compared to conventional systems. So in this particular lecture, we are going to discuss about the precast construction system, precast building systems. So there are four types of precast system. They are large panel systems, frame systems, slab column system with walls, and mix system. So this is depending on the load bearing structure. Depending on the load bearing structure, precast system are categorized into these following four types. So we will discuss large panel system first. The large panel system, as the name suggests, the designation large panel system refers to multi-story structures composed of large wall and floor concrete panels connected in the vertical and horizontal direction, so that the wall panels enclosed appropriate spaces for the rooms within the building. This process can be very well imagined if you consider your model making. So when you are working on your model, design model, so you use paper cuttings, you cut file card, you cut mount board, and then stick them to the place. So only difference is that is comparatively in a very smaller scale. This is in actual full scale. I will show you the image, then you will get the idea of the scale of this particular type of construction system. So these panels form a box-like structure. Both vertical and horizontal panels resist gravity load. Wall panels are usually 1 story high. So this is the scale. Horizontal floor and roof panels span either as one-way or two-way slabs. I hope you understand the concept of one-way and two-way slab. And when properly joined together, these horizontal elements act as diaphragms that transfers the lateral loads to the walls. So this is the actual scale of the construction systems of large panel system. So you can see you require equipments or a machinery to lift the heavy panels and place them at the actual place as per your design, and this has a particular design configuration or a building configuration. So in that way you have to develop the design. Now large panel system is further divided into three more types depending on the wall layout. There are three basic configurations of large panel systems. So first one is cross wall system. So the main walls that resist gravity and lateral loads are placed in the short direction of the building in cross wall systems. So you understand lateral load and longitudinal load. This is very important to understand this particular concept of large panel systems. So cross wall systems, the main wall that resists gravity and lateral loads are placed in the shorter direction of the building. In the building, if it's a rectangular, you have shorter direction and a longer direction. You get the concept of span in the shorter direction, same way. Then longitudinal wall systems. So the walls resisting gravity and lateral loads are placed in the longitudinal direction. Very basic. And then two-way systems. The walls are placed in both the direction. So this is just the configurations of wall, how you place in the direction of lateral load and longitudinal load to resist gravity. It is just about the regarding the placement of wall panels, the configuration. Okay. Then you have frame system. So what happens in frame systems is you have precast frames. Precast frames can be constructed using either linear elements or special beam column sub assemblages. Precast beam column sub assemblages have advantage that the connecting faces between the sub assemblages can be placed away from the critical frame region. I will show you the image and then you can understand what's going in this particular type of construction system. Linear elements are generally preferred because of difficulties associated with the forming, handling and erecting spatial elements. The use of linear elements generally means placing the connecting faces at the beam column junction. Let's see the another slide first. This is how the system of frame systems looks like. So you have various precast components like wall panels, reinforced cement concrete column, reinforced concrete girder. Girder is also called as beam. Reinforced concrete diaphragm. Diaphragm is nothing but a partition wall in this particular design, you can say. Then you have ceiling slab and then you have reinforced concrete foundation. All the elements are precast. You can see the elements are linear in one way, linear design. You can see two types of slab. Okay, number 4 and number 6 both are slabs. Fourth is the bracing slab and sixth is the ceiling slab. So this is just a system where you have all the elements or the components in reinforced cement concrete. They are precast. They are placed at their designed or desired position, and then one by one you are fixing the panels or the other components the way they are supposed to be placed as per the design. So comparatively it is very simple, but you require again the heavy machineries to lift these particular panels and place them at the desired position. I hope the image is self-explanatory and you can understand how the construction process is going to be taking over. The beams can be seated on corbels at the columns for ease of construction and to aid the shear transfer from the beam to column. So some manufacturers cast these precast columns with corbels. So corbels are nothing but where you rest the beams or the girder. So you have a certain projection or a protruding element where you rest your beam before securing it to the column by particular joinery. That can be either welding or a dry joint or a wet joint. The beam column joint accomplished in this way are hinged. Okay, so those are generally hinged joints. However, rigid beam column connections are used in some cases when the continuity of longitudinal reinforcement through the beam column joint needs to be ensured. So this depends upon the various manufacturer how he is going to provide the joinery for that particular element, precast RCC element. This thing is already explained. Then the next type of construction system is slab column system with shear wall. So this system rely on shear walls to sustain lateral load effects, whereas the slab column structure resist mainly on gravity. There are two main types in this category. First one is lift slab system with walls, and another one is pre-stressed slab column system. So we'll be seeing this one by one. So the first one is lift slab system with walls. So in lift slab system, the load bearing structure consists of precast reinforced concrete columns and slabs. As you can see in the images, you have precast columns which is running some 3 to 4 stories, and you can see there are precast slabs. Precast columns are usually 2 stories high. Usually 2 stories high they are, but that can be more also. You have to stack it one above the another. So all precast structural elements are assembled by means of special joints. As per the manufacturer, you have those special joints. Reinforced concrete slabs are poured on the ground in forms one on the top of the other. Okay, in the next slide the picture would be more clearer. Lift slab with walls. You can see in the bottom picture at the very bottom of the slide, starting from the left hand side. In the first image you can see the precast columns standing erect, and at the bottom or at the floor you can see multiple precast slabs are stacked one above the another. In the image adjacent to that, you can see one slab is lifted and placed at the very top. Similarly, in the adjoining image you can see a slab in between the two slabs. So what happens is, you are stacking all those slabs at the bottom when the columns are erected, and then you are lifting one by one, lifting all the slabs one by one. You can see 4 slabs are stacked in the first image, and you can see 4 slabs are placed at their desired location in the fourth image. So as simple as that. Precast concrete floor slabs are lifted from the ground up to the final height by lifting cranes. The slab panels are lifted to the top of the columns and then moved downwards to the final position. Temporary supports are used to keep the slabs in the position until the connection with the columns has been achieved. So this is also very simple techniques, but you require heavy machineries to lift these heavy slab panels. But the way of construction or the concept remains very simple. Then the next type is pre-stressed slab column systems. So the concept of pre-stressing, you have actually pre-stressing strands. The precast components are having what you can say cavities, wherein you can insert these pre-stressed strands and then you have to stretch them. I will explain the process later on. The pre-stressed slab column system uses horizontal pre-stressing in 2 orthogonal directions to achieve continuity. The precast concrete columns elements are 1 to 3 story high. So you have concrete columns, they are 1 to 3 story high, and then they have a cavity at the base of the column. Base in sense where at the floor part or at the roof part, where the floor or where the roof is supposed to get attached or joined. So there you have a cavity. Then reinforced concrete floor slabs fit the clear span between the columns. After erecting the slab and columns of the story, the columns and floor slabs are pre-stressed by means of pre-stressing tendons, which I was referring earlier, that pass through the ducts in the columns at the floor level and along the gaps left between the adjacent slabs. So you fix the slabs or you lay the slabs in between the columns. For example, there are 4 columns at the 4 ends of the room, and you place the slab, RCC slab, within those 4 columns. Okay, and then by the means of these pre-stressing tendons which is passing through the slabs, passing through the cavities in the slab and the cavities left in the column, so that is going through the slab and the column, and that is pre-stressed. Pre-stressed is something like stretching on both the ends. As we have said earlier, pre-stressing is done in both the orthographic directions, orthogonal directions, x and y axis. So tendons are stretched in both the directions, and then it is secured. After pre-stressing, the gaps between the slabs are filled with in situ concrete, and the tendons then become bonded with the spans. So having stretched those tendons, you are going to pour the concrete there, in situ concrete you can say, and thus the joineries are secured. Seismic loads are resisted mainly by shear walls, precast or cast in place, positioned in between columns at appropriate location. In the adjoining figure, you can see pre-stressed strands or the tendons. You can see your column, and you can see adjacent slabs on both the direction, and you can see the tendons passing through the slab, the column, and the adjacent slab. So single pre-stressed tendon in passing through two slabs and a column, and that is stretched in both the direction. Two tendons you have, one is in z-axis, one is in x-axis. So both of them are stretched, and then you are pouring the in situ concrete to secure the joint. So in that way, this way of construction takes place. So little bit complicated to understand as compared to the previous types, but this two can be understood very well if you understand the concept of pre-stressing. Okay, so this is the end of this particular type. In case of difficulties, we can have a discussion session on this.